Section 3.3. A z-score is the number of standard deviations that is the given value x is above or below the mean. The z-score can be calculated by using one of these two formulas. If you have a sample, z is going to be your x minus the mean divided by the standard deviation. If you have a population, z is going to be equal to x minus the mean divided by the standard deviation. For the z-score, we always round it to 2 decimal places. Example 1. Which of the following two data values is more extreme relative to the data set from which it came from? The 4,000 gram weight of a newborn baby, a month 400 weights with a sample mean of 3,152 grams, and the sample standard deviation of 693.4 grams. Or the 99-degree Fahrenheit temperature of adult among 106 adults with a sample mean of 89.20 degree and the sample standard deviation of 0.62 degree. So they want me to compare the 4,000 gram and the 99 degree. I cannot compare these two directly. They are from two different categories. If I want to compare these two, I have to convert them into a z-score. So let's do it. So over here I have x is 4,000. So I have the weight of the babies on the left side and the degree of an adult on the right side. And I want to find the z-score for these two. Z equals x minus x bar over s. So my x is 4,000, my x bar is 3,152.0, over my s is 693.4. So I got 848 divided by 693.4, and I end up with 1.222959331. So for the z-score, I will always round it to 2 decimal places. So I have z is 1.22. And I would do the same thing for the other data as well. So I have x minus x bar over s. 99 minus 98.20 is 0.80 divided by 0.62. Give me 1.290322581, and I am going to round it to 2 decimal places. At this point, we are going to compare 1.22, which is the z-score of 4,000 gram, and 1.29, which is the z-score of 99. Because 1.29 is greater than 1.22, that means 99 is more extreme than 4,000. We can also use the z-scores to identify the significant values. If the data values have the z-score in between -2 and 2, the values are not significant. If the data values have the z-score of 2 or greater, the values are significantly high. If the values have the z-score of -2 or less, the value is significantly low. Example 2. The lowest platelet count in a dataset is 75. Is that value significantly low? Assume that the platelet counts have a mean of 239.4 and standard deviation of 64.2. So they're asking if this 75 is significantly low. And your answer is yes or no, right? So what you are going to do is you are going to find the z-score for 75. If the z-score for 75 is -2 or less, then 75 is significantly low. So z-score equals x minus x bar over s. My x is 75, my x bar is 239.4, my s is 64.2. And I have negative 164.4 divided by 64.2, and I get negative 2.5607476664. For a z-score, I am going to round it to 2 decimal places. So that is going to be negative 2.56. So 75 has a z-score of negative 2.56, which is negative 2 or less. Then 75 is significantly low. Percentile. Percentiles are measures of location, denoted by P1, P2, P3, all the way to P99, which divide a set of data into 100 groups with about 1% of the values in each group. P1 means there will be 1% below this number and 99% above. P2 means there will be 2% below this number and 98% above. If you have P5, that means 5% below that number and 95% above. P99 means 99% below and 1% above. To find the percentile of a certain value of x, you are going to rearrange the data values from least to greatest, and then you're going to count the number of values that less than x, divided by the total values, and multiply by 100. For example, I have the list of 50 data values, and this is already arranged from the smallest to the greatest for me. And they want me to find the percentile for 11.8. So they want me to find the percentile for 11.8. To find the percentile for 11.8, I am going to take the number of values less than 11.8, divided by the total number of values, and multiply by 100. So this is 11.8. There are 20 values that is less than 11.8. So I have 20 values that's less than 11.8, and over the total number of values, which is 50, and multiply by 100. And I have 40. So that means 11.8 is the 40th percentile. Or you can call it P40. Now, what does that mean? It means that there will be 40% of the data values that's below 11.8, and 60% will be above 11.8. So if you look at this, below 11.8, there are 40% of the values. Above 11.8, there are about 60% of the data value. So N stands for the total number of values, or it can be also called the sample size. K is the percentile being used. For example, if it's a 25th percentile, K is 25. L is the locator that gives the position of the value. For example, for the 12th value in the sorted list, L is 12. PK is the kth percentile. For example, P25 means that's the 25th percentile. So to convert from a percentile back to a data value, we are going to follow these steps. So first, we started with sorting the data from the least to the greatest. Again, it has to be from the least to the greatest. Then you are going to compute the locator, which is L. To find L, you take K over 100 times N. And then after you find L, you're going to ask yourself, is L a whole number? If L is a whole number, you are going to follow this direction. If L is not a whole number, you're going to follow this direction. If L is a whole number, the value of the K percentile is the midway between L and the next value. If L is not a whole number, we are going to round it up to the next whole number, and that is the location for your percentile. Example 4. I have a table of 50 values, and they want me to find the 40th percentile, or the P40. So the first thing I'm going to do is always sort it from the smallest to the greatest. And then I am going to find L, which is my locator. L equals to K over 100 times N. K is the percentile right here. So P40 means K is 40, or 40th percentile, K is also 40. So I have 40 over 100 times 50. So I get 0.4 times 50, which is 20. So after I got 20, 20 is not my value. 20 is telling me where it's going to be. Now, because 20 is a whole number, so my P40 is going to be in between the 20th and the 21st value. So my 20th value is 11.6, and my 21st value is 11.8, and I am going to find the average of these two. And that is 11.7. Quartiles. Quartiles are measures of location denoted Q1, Q2, and Q3, which divide a set of data into 4 groups with about 25% of the values in each group. Q1 is also called the first quartile, and also the same value as P25. It separates the bottom 25% of the sorted values from the top 75%. Q2, the second quartile, same as P50 and also same as the median. It separates from the bottom 50% of the sorted values from the top 50%. Q3, third quartile, same as P75. It separates the bottom 75% of the sorted values from the top 25%. To find the interquartile range, or IQR, we take Q3 minus Q1. Semi-interquartile range, Q3 minus Q1 divided by 2. Mid-quartile range, Q3 plus Q1 divided by 2. 1090 quartile range, P90 minus P10. 5-number summary. For a set of data, the 5-number summary consists of these 5 values. First is the minimum value. Second is the first quartile. Then you have the second quartile, also known as the median, third quartile, and the maximum. So if the question is asked for a 5-number summary, they are asking for these 5 numbers. Example 5. Use the Verizon Airport data speeds to find the 5-number summary. So the 5-number summaries are the minimum, Q1, Q2, Q3, and the maximum. I already have the minimum and the maximum. For Q1, I just find the number right in the middle. The data is already sorted from the mean to the max. I have total of 50 values. My median should be in between the 25th and the 26th value. So I have 10, 20, 21, 22, 23, 24, 25. So my median should be in here. It's in the middle, in between 13.7 and 14.1. So what I'm going to do is take 13.7 plus 14.1 divided by 2. To find Q1, I just find the median of the first half. So from 0.8 to 13.7, I want to find the number right in the middle. So these are 25 values. The number in the middle is the 13th one. So 10, 11, 12, 13. Should be this. It should have 12 values on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is my Q1. Similar to Q3, from 14.1 all the way to 77.8, I want to find the middle number. So there are 25 values. The middle number should be at the 13th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 21.5. And these are my 5-number summary. To find the 5-number summary, first we need to import the data into StatCrunch. Then click on Stat, Summary Stats, Columns. Choose a column. In this box, we need the median, the min, the max, Q1 and Q3. This is your 5-number summary. A box plot is a graph of a data set that consists of a line extending from the minimum value to the maximum value, and a box with the lines drawn at the first quartile, median, and the third quartile. Use the Verizon Airport data speech to construct a box plot. To construct a box plot, we are going to need the 5-number summary. We already found it in the previous example, so I am going to just write it down. So when you write a 5-number summary, it should be in this order: the minimum, Q1, Q2, Q3, and maximum. Next, we are going to create a number line that is long enough to contain 0.8 all the way up to 77.8. We will first draw in the box starting from Q1 to Q3. So 7.9 all the way to 21.1. So this is Q1 and this is Q3. And in the middle, we're going to draw the line at the median. So median is 13.9, somewhere here. So this box tells me about Q1, Q2, and Q3. My minimum is at 0.8, so I'm going to put a dot at 0.8. And I will connect from 0.8 all the way to Q1. My maximum is at 77.8, so I put a dot right here. And I'll connect the line from Q3 all the way to the dot. And this is called the box plot. by looking at this box plot, I know that this data is skewed to the right because I have a longer right tail. A box plot can often be used to identify the skewness. A distribution of data is skewed if it's not symmetric and extends more on one side than the other. To identify the outliers, I need Q1 and Q3. My Q1 is 7.9 and my Q3 is 21.5. The first step I am going to do is find the IQR, interquartile range. IQR is Q3 minus Q1. Which is 13.6. The second step is to find the lower fence, or can also be called the lower outlier boundary, which is Q1 minus 1.5 times IQR, which is 7.9 minus 1.5 times 13.6, negative 12.5. Step 3 is to find the upper fence, or can also be called the upper outlier boundary, Q3 plus 1.5 IQR, which is 21.5 plus 1.5 times 13.6, which is 41.9. Last step, I am going to identify my outliers. I am going to use these two numbers. So first I need to place these two numbers in the order of my data values. Negative 12.5, if I want to place the number on here, it should be before 0.8. $41.9, if I want to place it on here, it should be right here in between 38.5 and 43. So any number that's lower than this negative 12.9 will be outliers, but I have none of those because my minimum was 0.8. And any number that's greater than 41.9 are also outliers. So in this case, I have 1, 2, 3, 4 outliers. Example 7, construct a modified box plot. So what is the difference between the regular box plot and the modified box plot? Modified box plot will tell you what the outliers are, and you can only have modified box plot if there's outliers. So the same concept, I am going to need a number line. I also need my 5-number summary. I am going to first draw the box from my Q1 all the way to Q3. And then I draw a line at my median. In order to have a modified box plot, I need to have outliers. I have 4 outliers in this problem: 43, 55.6, 71.3, 77.8. I am going to put a dot above these numbers. These dots represent the outlier. Now I need to draw the line from Q3, but I don't know where to stop. So if you look at the data here, you are going to stop at the largest number that is not outlier. So that is 38.5. On this side, I need to draw the line from Q3 to the side. Since I didn't have any outlier on the lower end, I'll still draw the line from Q3 to the minimum. And this is called a modified box plot. To construct the box plot on StatCrunch, we first need to import the data into StatCrunch. Graph, box plot. Choose the correct data. Check this box to make sure that it's horizontally. For this one, if you want a regular box plot, uncheck the box. This is a regular box plot. If you want to construct a modified box plot, then you check the box. This is a modified box plot where they tell you your outlier.